Welcome to the release of the Model HTV Unpurged Thermocouple. The HTV marks a new, reliable thermocouple alternative by Delta Controls for sulfur plants and is the result of 49 years of engineering expertise in designing thermocouples for some of the most challenging applications in petroleum and gas refining. The HTV brings forth several new innovations, providing plants with reliable options between proven purged thermocouple technology and the latest unpurged technology from Delta Controls. In sulfur recovery and other sulfur processing services, the high temperatures and corrosive process gases can cause thermocouple elements to deteriorate quickly if not properly protected from the challenging atmosphere. With plant runtimes now planned for up to 7 years and elevated operating temperatures, highly reliable temperature indication is critical for the safety and reliability of the sulfur plant. For nearly 50 years, the industry has relied on Delta Controls purged thermocouples for turnaround-to-turnaround reliability. With over 130 sulfur plants utilizing this technology internationally, it's evident why Delta's purged thermocouples have become the standard for reliability. Even with the proven reliability, installing and maintaining a purge system may not be ideal for some plants. Failure to operate this system correctly can compromise the elements within a matter of weeks. We've received many requests over the years for an unpurged alternative, but we're always concerned with the reliability of such designs. Even with monocrystalline thermowells and other advanced sealing methods, unpurged thermocouples are tasked with isolating the elements, or attempting to, for 5+ years in a 3,000+ degree environment. The challenge of protecting the thermocouple elements for such a duration relates to the diffusion and accumulation of trace process gases within the thermocouple assembly. Even the most advanced seals and thermowell materials cannot isolate the elements completely. Commonly, unpurged thermocouple designs integrate a monocrystalline sapphire thermowell as a primary barrier against process gas diffusion. The absence of grain boundaries in monocrystalline sapphire can slow the diffusion of process gases through the thermowell, but it is unknown whether the diffusion rate is sufficiently minimized to prevent thermocouple deterioration for the targeted 5 to 7 years between turnarounds. Even with the thermowell material serving as the primary barrier, trace amounts of process gases will still diffuse through the thermocouple seals and accumulate within the internal assembly. Over time, these gases can diffuse through the sapphire thermowell seals and accumulate within the element atmosphere, leading to gradual degradation of the thermocouple elements. For these reasons, Delta Controls has always been hesitant to develop an unpurged alternative, employing a design that does not contemplate and address these reliability concerns until our research and development team conceptualized what is now designated as Q-Seal. Q-Seal is a patent-pending system that overcomes the reliability issues related to unpurged thermocouples by ensuring diffused process gases are maintained at atmospheric concentrations within the thermocouple assembly, and therefore protecting the elements from degradation. We name this technology Q-Seal as an abbreviation for equilibrium sealing. Equilibrium in this context refers to the notion of a gas becoming uniformly distributed by reaching atmospheric equilibrium, and such equilibrium is reached through the diffusion of gases seeking equal concentrations. Now let's go over how Q-Seal is integrated into a thermocouple design, here with the Model HTV, the Delta Controls thermocouple model available with this new technology. From the outside, the HTV may appear to be similar to other unpurged designs, but its innovations all relate to how it internally addresses diffused process gases. Our R&D team first carefully designed each thermowell to seal at respective locations within the thermocouple assembly, starting closest to the process with the primary thermowell, then the secondary thermowell, then element support, and last, the seals against the thermocouple elements. While in service, trace gases diffuse through the primary thermal well seals and eventually accumulate in the atmosphere between the primary and secondary thermal wells. The accumulated gases then diffuse upwards into the interior cavity closest to the process that seals against the silicon carbide primary thermal well. As the interior concentrations increase, trace gases then diffuse to the next interior cavity. To prevent further diffusion within the thermocouple assembly, our team implemented what we are calling the isolated seal breather, which is a clever mechanism that ensures atmospheric concentrations are maintained and further gas diffusion is prevented. The isolated seal breather is carefully positioned. The remaining 3 sealing mechanisms, one to the sapphire secondary thermal well, another to the element support, and the third to the thermocouple element, provide redundant seal protection in the event of thermal well breakage. If the thermal well were to break during an upset event, process gases moving through the secondary sapphire thermal well would be isolated from the atmosphere by the sealing system. Diffusion ensures gases maintain atmospheric concentrations instead of diffusing into the secondary sapphire thermal well or accumulating within the upper cavities of the thermocouple, which would then diffuse through upper seals and bypass the secondary thermal well altogether. With Q-Seal, it is important to note that any leakage or diffusion through and around the seals does so in only trace quantities. The leakage rates are lower than from a standard metal flange gasket on the reactor. Nevertheless, if these trace gas amounts were allowed to accumulate in the upper portion of the thermocouple body over time, the thermocouple elements could be compromised. The Q-Seal system is the result of years of diligent efforts by our team and is truly a novel means to protect thermocouple elements. With all of the Delta Controls experience and institutional knowledge, we are confident this is the most reliable unpurged alternative for the sulfur industry.